Assalamualaikum and a very good evening to my panel, Associate Professor Dr. Felix and Dr. Faizal Pakir. Today I would like to present my final year project, which is numerical study on soft soil improvement by using lightweight material. Okay, here is my presentation outline. So I will talk about research background, problem statements, objective of the study, scope of study, significance of study, literature review, site and material selection, soil sampling, engineering properties of EPS, numerical modeling, data analysis, and lastly expected result. The issue of soft soil in Malaysia has received considerable critical attention as it is one of the challenges of civil engineers in construction industry. As development rates at a rapid pace, the projects are progressively being located on poor ground condition. And as we all know, the satisfactory of soil properties and characteristics plays important role in geotechnical construction industry. If the soil has insufficient properties, engineers must find a way to resolve the local soil mechanical and chemical problems. The geotechnical engineering field faces many soft soil construction related issues. The development of large urban area as well as industry and strategic location are factors contributing to land use without modification. In addition, the method of replacing of soil with quality material is very expensive. So, there also have been many infrastructure projects and high-rise building costs where its foundations are often supported by such low shear resistance and high compressibility of soil. And according to Nordin, one researcher, the clay in the area of Batu Pahat is low shear strength and large compressibility soil. In the same vein, some other researchers also said that Batu Pahat soft clay were low in shear strength, bearing capacity, and suffer large settlement when subject to loading. The objective of the study are: for the first one is to investigate the lightweight material properties and the soil properties that will be used in experimental study. The second one is to minimize the settlement of soft soil by replacing with lightweight material. And the third one is to analyze the performance of lightweight material as a soft soil replacement material by using numerical modeling, which is Plexis 2D. This research focus on the substitute lightweight material in the subgrade. The engineering characteristic of the soil and lightweight material would be determined throughout the laboratory testing and critical comprehensive review for the past literature. Then, the Plexis 2D will be used to do the modeling of the embankment with the laboratory information from sample collected at research. This is the significance of the study. At the end of the research, hopefully this simulation can help future researchers to design and make improvement of soil safely, economically, and effectively. Settlement are vertical deformations of the mass of soil as a result of applied stress causing vertical movement of the supported structure. In structural geotechnical assessment, settlement is one of the safety performance factors that need to be taken into account. This picture shows the types of settlement occur in various ways, which is uniform settlement, thick settlement, and non-uniform settlement. There are lots of cases that happen due to the settlement of soft soil, and one of the case study is the Hospital Tengku Ampuan Rahimah Klang. Then the figure below shows the Batu Pahat soft soil characteristic that is taken from some literature. There are a lot of ground improvement methods that we all know, but here I want to highlight on the EPS and bamboo grid cell. EPS has low density, insulation to protect subgrade from the frost penetration, and as we all know, the nominal density, which is from 12 kg per meter cube to 32 kg per meter cube. For the bamboo grid cell, it increased the value of the unconfined compressive strength, and also soil reinforcement is better than geotextiles. And last one is bamboo can be easily obtained, trunk strong, resilient, straight, and easy to use. This is the numerical modeling that we are familiar with which is Plexis and FLEC. Plexis is developed by Plexis, simple and practical, acceptable result, and also finite element program with implicit integration used for design, and also can be considered at the lowest tier amongst these soft codes. But the cost of software is expensive compared to the FLEC. Okay, as we all know, there is a lot of models in Plexis, but what I want to highlight here is hardening soil and soft soil model, because I use hardening soil to model the EPS and soft soil to model the clay. And as we all know, the hardening soil model is an advanced model for the simulation of soil behavior. It is extension of molecular model, and soft soil model is a clay type model, especially means for primary compression and near normally consolidated clay type soil. This shows the parameters that we need to get in order to use this model. This is research methodology flowchart. I start with site survey and soil properties investigation to compile the objective one, and the next one I use EPS in soil improvement by getting know the EPS characteristic, and also the last one is to analyze the performance EPS on soft soil improvement by using Plexis software, and then I do the result analysis and then conclusion and recommendation. This is site investigation that I choose, which is at resuscitation, and also the material I choose for lightweight fill is EPS. The soil sampling involved is saturated soil and unsaturated sampling soil, and this shows the soil sampling that I will do at the recess. There are lots such as bulk density, water content, organic content, and all of these to know the characteristic of the soil at recess. This is the engineering properties of EPS that I will use for modeling. Is extracted from another researcher that I will use 3 types of density for modeling, and also I will use different height of EPS. And the analysis will carry out in different density and thickness of EPS as I told earlier, and the density are 20, 30, 40 kg per meter cube, and also 1 meter, 2 meter, and 3 meter respectively. This is the geometric modeling of embankment that I will model in Plexis. The embankment has a base width of 40 meter and 8 meter top width, and the total height of embankment is 4.9 meter, because the range of common height of embankment that be constructed on soft ground in Malaysia is between 4 to 5.5 meter. The result of the numerical predictions are compared in terms of settlement. The variable parameter used are different EPS density and different EPS thickness. Hence, the graph of different density versus settlement and also different thickness versus settlement would be plotted. What I expected at the end of the study is from this numerical study, it is expected to give different perspective or outcome that will contribute to development of new lightweight material to reduce soil settlement. That's all from me today. Thank you for watching.